Aloha, Richard Halverson here. This is ITS148, and today is March 31st. And today we're going to start with sorting. And so today is actually around here, but we haven't. So we're going to cover sorting algorithms, and we could possibly get into this. I split this into two just because normal sorting algorithms are O of n squared complexity, and fast sorting algorithms are O of n log n complexity, and so that's a nice way to divide them. But I don't know. To learn these sorting algorithms, it's better if you just step through the algorithms yourself and follow them in your mind rather than my trying to explain them to you, because I will undoubtedly say the wrong thing now and then, and it only confuses you. But anyway, so I forgot to upload last week's video, so I'll make sure I do that after this is over. And oh, I did fix assignment 2. So assignment 2 is there. It's pretty easy, it's pretty straightforward. So let's go to the textbook. By the way, so if anybody in this class wants to take ITS148J next semester, you can. This is the only. You only need this course as a prerequisite. You don't need 228. And the textbook is going to be a Zybooks book, and I'm going to include some chapters out of this textbook. It's actually out of this textbook, but the Java version of it. So it should be pretty easy for you, pretty straightforward to pick up Java, because you'll be familiar with all of this, and you're learning all this right now. You're learning all of these algorithms using Python, but Java is the second most popular language. Python is the first most popular language. Java is the second. Java is a language better for large productions. It's statically typed. It's designed. It's compiled instead of being interpreted, and so it's much better. It's much better for production environments, whereas Python is much good for experimental environments. Anyway, so let's start looking at the sorting algorithms, and these are just regular sorting algorithms here: selection, bubble, and insertion. And there's a lot of exchanging that goes on, and they're all very similar. And sometimes you get them mixed up in your head, and there's actually variations that are combinations of concepts of each. We can start. Okay, sorting is a process of taking a list that's not in order and making them be in order. And so here it's swapping is used in all sorting algorithms, because you're having elements switch places, and it's just you go through the list and you have elements switch places, and it turns out that for chapter 16 sorting algorithms, you generally have to go through the list twice, or for each time you go through the list, you have to go through the list again. So it's like as you go through the list from beginning to end, each time you visit another element, you have to go through the list again. So that's why it's the number of times through the list squared. So let's take a look at this. So this is kind of a fun game here. We're supposed to sort the numbers from smallest on the left to largest on the right, select two numbers, then click swap values. Let's see what this, okay, I don't remember this one. So I'm supposed to take 2. 0, 9, 12, 80, 85. I'm going to swap. I'm going to swap these two. And I'm going to swap these two. You know, now these first 4 are sorted. Oh, I'm going to swap these two. And I'm going to swap these two. Okay, now it's sorted. Took me a long time. Anyway, so you can do that. That's kind of fun. The list is sorted into ascending order. Great, greater, greatest. So for these kinds of, for sorting words like this, you start with the first letter. It's the same. So then you go to the second letter, R, 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 same, E, 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 A, A, T. And so this one looks like it's first because it's done after 5. This one is done after E, R, and E, S. Okay, so E, R, R, the R is greater than S. So it is in order. So anyway, you can make sure you understand sorting both numbers and words. So selection sort's probably the easiest sort. Now it's debatable. But you basically, let's see, there's various, let's see how this one works. I think sorting algorithm treats input as 2 parts, the sorted part and the unsorted part, and repeatedly selects the proper next move, the proper next value to move from the unsorted part to the sorted part. Okay, so it's probably gonna start, okay, let's just see how this works and I can explain it as we go. So we start out, okay, here's an algorithm. Here's this is the Python program. Okay, so it starts with in the range length of numbers -1. So it starts, so I goes from the highest one to the lowest one. I in the range of the length of the numbers, no, I'm sorry, it goes from the lowest to the highest, from the lowest to the highest. And then the next one in here goes from the next one on up. And so it starts out where the outer loop is I, that's this one, and the inner loop starts with I plus 1. So the inner loop J starts with this value, and then so from here, it went through the rest of them and found the smallest one. And so now the smallest one is 3. No, wait, no, I'm sorry. It's comparing 7 with all of them. And oh, it finds the smallest one. Okay, got it. And then it's going to exchange them. And now 3 is in its proper place. Then it's going to do 9. It's going to find the right out of the last 3. It's going to find the right one that goes into the position that's 9 is in. So so now it starts there, and then it looks at 7 and 9, and then it looks at 18 and 9. It looks at 8 and 9, and 7 was the smallest one, so it exchanges that. And the third, so 9 is in its proper place. No, 7 is in its, so then it looks at and tries to find the smallest one for that one, and then it continues on. So each time it starts with the first one, and it says, okay, that's sorted. Let's see, no, I'm confusing sorts. Anyway, so go through this, make sure you understand it. I'm just terrible at explaining it, which is why it's bad that I started explaining it in the first place. But selection sort has the advantage of being easy to code, involving one nested loop within another, as shown below. See if there's another. It's O(n) squared. It explains that. I'm going to click through this again and see if I can see if it's clearer the second time. Okay, so we start with the first two, I and J, and then J goes. Okay, so it keeps track of the smallest index here, and as it compares down the line, it keeps track of the smallest one, and then when it's all done, it exchanges that smallest index with the position that I is in. See, so now let's do the next one. Okay, that's exchanging, and then now it goes to the next one, and it goes through all the remaining. It goes through all these four to find the smallest one, and it's going to exchange it with 9. So 7 is exchanged with 9. And then it's going to do 9, 18, and 8, and 9 and 8 are going to exchange. And then the last loop, it just has 18 and 9 to do, and it sees that 9 is less than 18, so that exchanges. Okay, so that's selection sort. And you can go through that to see. Bubble sort is different. Bubble sort, you're only exchanging adjacent elements. And is there a step through here? There's not. There's no step through, huh? Okay, well, with bubble sort, really, it doesn't even show what's next. Insertion sort actually shows you something. Well, let's see. I'm going to go bubble sort animation. Sorry, I'm wasting your time. Never mind. It would be good to go through it and see how that works. It basically has an inner loop and an outer loop. It has an outer loop and an inner loop, and they both start I equals 0, and I and j equals 0, but j only goes up to the I goes through all the numbers, and j goes up to it goes up to the second to the last one, and the bubbling bubbles if j is greater than the one right after it, then it exchanges them. And so the biggest one bubbles all the way down to the bottom, then the second biggest one, then the third biggest one, and the fourth biggest one, and the sorted list is built that way. All right, insertion sort is where you start with a single element that you say, okay, if there's just one element in your list that's sorted, and then you add a new element to the tail of the list, and that new element that you add to the tail of the list bubbles. You can use the term bubble. It bubbles up to its proper position, and then once it's done that, then you've got two that are sorted, and then so you keep on adding the new ones onto the tail of the list. Each time you tack it onto the tail of the list, you bubble that item by swapping until it lands in its proper place, sorted place. So if we let's see. Oh, I'm sorry. Oops. Let me start from the beginning. Start. Okay, so it starts with the first one, and j equals 1. Okay, so here it's exchanging. And then, so now these two are sorted. Anyway, you can follow through this and concentrate on it and see how that works. And this figures out the computational complexity. For all of these, there's an inner loop and an outer loop, and they both grow as n grows. So the inner loop doesn't grow quite as fast as the outer loop because it does less. The outer loop always goes through all of them. The inner loop doesn't always go through all of them. Nonetheless, it's n squared. It's polynomial squared. It's a squared polynomial algorithm. So so all three of these first sorts are similar in that way, and they're n squared algorithms. Now some of these are more suited depending on your application. If you have a sorted list and you have new elements coming into the list, now and then an insertion sort is best, because you have a sorted list and you're adding one new item to the list, and it bubbles in. If you were to use a selection sort or a bubble sort, then you would have to resort the list each time you add an element. So that's an example, and this kind of goes through that example of insertion sort and why that it is best in a lot of cases. All right, so shell sort is a little bit different, and it sorts interleaved lists, and there's this gap value thing, and so you can step through this to try to make sure you understand this. And this is the algorithm. And so it's the kind of thing where you want to step through it and understand how it works in your head once, and you get enlightened. And then you probably, if you ever have to actually program this, of course, you just do a Google search and find the algorithm and make the adjustments. But the computational complexity is a little bit better than O of n squared. It's O of n to the 1.5. This will show you this will give you an animation of how it works. And here's a challenge activity. Step through that. And here's a lab. I tell you what, I'm gonna jumble up these labs all in one video, just because. Oh, I guess we are at the end. Oh, okay. Well, then I guess I'll do the lab. What time is it? Okay. I thought this was a lab at the beginning of the video. So I thought this was a lab in the middle of the chapter. Some of the chapters are that way. So why don't I do this last? Okay. Write a program that takes an integer list, it sorts the list into descending order using selection sort. Okay. The program should use nested loops and output the list after each iteration of the outer loop, thus outputting the list n minus 1 times, where n is the size of the list. Okay, so if the input is like that, all right, so we are, well, gee, this is sicker. Okay, so I'm going to go to selection sort, and I'm going to copy some code. Okay, I'm going to copy this code here. Copy. That's code to copy. Go back over here. And let's just, first of all, start by pasting it. Okay. Now it's supposed to input. So what does this do? This doesn't input. This let's see. Number string equals input, whatever. And then how do I convert that to numbers equals this int x. I'm trying to do a I want to do a comp. This comprehension. I'm going to do a comprehension. So I mean, I don't remember the syntax, so I'm going to open up a new tab, and I want to do this for. Oh, it's just a for loop for iterative. Okay. Okay, but anyway, it's for I in list. Okay, so just like that. Great. For x in number string split. Okay, something like that. Okay, so now this will be a list of numbers, and then I call selection sort to sort it, and I guess this will print it at the end. All right, I'm just going to see if this works. I'm going to try putting in these numbers. Why not? And I'm going to see what this does. So this is the numbers, and I'm going to run it. And okay, so the sorting works. Okay, I don't need to print out the word sorted. So I'm going to not print this out. That's at the end. It prints this out. Oh, I want to sort in descending order, don't I? So I got to change this to descending. How about if I just do this? I'll change the less than to a greater than. Now I'm going to run it. Oh, look, now it's in descending order. But I'm supposed to print it out each time, aren't I? So This is printing it. I'm going to copy this, and I'm going to put the print statement right here. I'm going to put the print right here inside the selection sort, inside the for loop, inside this for loop. Okay. Oh, wait a second. No, I'm supposed to print it just like that. So I don't need to get fancy at all. I just need to do print. I just need to print numbers, don't I? Yeah. And then I don't need this either, do I? All right, let's see what this does. Whoa, that's pretty close. Yep. Well, you should be able to finish. All right, what's next? Words in a range. There we are. Wait, what? Hold on. I'm sorry, oops. Insertion sort. Here's where we are. All right, insertion sort. The script has 4 steps. Read a list of integers, output the numbers in the list, perform an insertion sort on the list, and output the number of comparisons and swaps performed during the insertion sort. Okay. Steps 1 and 2 are provided. Implement step 3 based on the insertion sort algorithm in the book. Modify the insertion sort to do these things. And then implement step 4 at the end of the script, which is to write out stuff. Okay, great, nice. Okay, insertion sort. That's got a swap function. Yes, that's how you can swap in Python. This prints out the numbers, this reads the numbers. This is the insertion sort right here. Okay, so we gotta fix this so it works. All right, I'm gonna stick these numbers in there and see what it does right now. Okay, it doesn't do anything. So these are just some functions there. Okay, this is the, all right. So reads the numbers, outputs the numbers, calls insertion sort doesn't do anything. Okay. Okay, for I in the range, let me go back here. Find insertion sort. All right, I'm gonna break this out. So over here, put this back here, make this be there we go. Here's the insertion sort from the book, and here's my code over here. Insertion sort numbers for I in range of the length of numbers, j equals I, while j is greater than 0 and numbers is greater than the one just below it, while j is greater than 0 and numbers of j is less than the numbers below it. Okay, numbers j should be greater than the one before. Okay, this is the one before it, and this is the one after it. And if the one after it is less than the one before it, then we want to swap them. That's what this does. Swap does this, and then that's this. This is swap. That's this. And then we just decrement j. That's the same thing. This is the same as this. Now, what are we supposed to do? We're supposed to count comparisons and count swaps, huh? Do I need to do some kind of some kind of global thing or something? Okay. I'm going to do comparisons equals 0 and swaps equals 0. And I'm going to say I don't know. All right. Comparisons. One, I think I got to say something like global or something. I have to say something like global comparisons, swaps. I think I got to do something like that. Let me see. Python global variables. Global keyword. Okay. So you have X out here, but if you make it global here, then it's going to change this X. Okay, so that's what I want to do. All right, and swaps. Where do I add swaps? Oh, this comparisons is the same as swaps. I'm not adding comparisons right now. I think comparisons should be out here. And swaps should be in here. Now I could put the incrementing of the swaps in here and make it global, but I'm just going to put them here because this calls swaps, this increments it just before it calls it. And then I guess someplace I got to output print. Oh, what does it look like? Comparisons and swaps. Print comparisons. And then print swaps. All right, let's see what this does. Comparison 7 swaps 4. Is it the same thing? Comparisons 5 and swaps 4. Oh, I should print this out too, I suppose. I guess every loop, every outer loop, huh? So it'd be right here. Print numbers. Numbers, okay. All right, let's see what this does. Two, three, four, five. Oh, it shouldn't. I shouldn't do it like that. I should do it like this. Okay, so print nubs. Sorry, I should say print nubs. Oh, I should use read nubs too. I do use read nubs. Okay, let's just look at it. Oops. Okay, anyway, it's got the number of comparisons wrong. How do I? Oh, wait a second. Oh, oh, that's right. There could be more than one comparison here. So, I let's see something. Swaps is 4. Swaps is right, but comparisons is not right. I guess I'm missing out on comparisons. Let's see what the, well, you know, I think I'm going to leave this for you to work on. Okay, so somewhere I'm counting the comparisons wrong. And so I think I'll leave it for you to fix. You think you can fix it?
Yeah, I think so.
Okay, all right, good. All right. Okay, so I guess that's really all I have for today. And next, as you see, I did post up the assignment. It's pretty simple. It's just implementing binary search both recursively and not, and I show you where the algorithms are and so on. So,
so it's the same process as assignment 1. You just grade it in that grading thing.
yes, it'll be the, yeah. And I don't think the grading thing is up yet, but yes, yes, it'll be just like
okay.
And you know, the grading, I may be a little slow getting the auto grader up because these are all new assignments for me. But so you know, try to. I really should be getting you to come up with test data yourself, because you know in the real world you have to, you aren't just given test data. And so I have kind of a justification for being slow, but of course you know it's you can it's the it's whether or not it works at the very end, which is when you get all your points. So it's okay that you know you spend some time and maybe you can't quite get it, and then finally at the very end, you know, the grader, the auto grader will be there, and you'll be able to confirm at that time. So you know, don't worry if it's you know, you aren't getting them done by a certain time, because you know you always have till the end of the semester. So I'm sorry for not getting the auto grader stuff up sooner, but I'm actually doing this now in all my classes, and so it takes me a little while to catch up on getting the auto grader to test your stuff the right way and give you clues when, because I have to anticipate that things you're doing wrong, that you may do wrong also, so I can check for those. Anyway, all right, so I will I'll sign off here and see you next time. Do you have any other questions?
Um, I'm doing okay. Yeah.
All right. Okay, good.
Okay, thank you.
You take care.
All right, bye.